Okay, so we're back and we're going to do lesson 2.3 part 1 tonight. So we'll do half tonight. Then next Tuesday, we'll do the other half of 2.3 and work on 2.4, whatever we can get done. So it says 88 miles per hour. And we've done a little bit of this in unit 1. It says the quote is, the future is something which everyone reaches at the rate of 60 minutes an hour. Whatever he does, whoever he is. We also do it at the rate of 24 hours per day, right? So those are all rates that we use to move life along. So 88 miles per hour is a rate of change. And we talked about rate of change. We came up with a couple of those when we did unit rates and rates in lesson 1, unit 1, if everybody remembers that. And down here, it says a rate is a ratio comparing two quantities. And then I'm going to let you ladies work, read through here. And this first part is pretty self-explanatory. So I'll be here and answer questions.
You'd make $500 in 5 days.
Everybody's in agreement with that?
I don't know if that's equivalent rates, but it's what you get.
We have a new math student.
Oh, hiya.
Yeah.
So does everybody think that they're equivalent? $100 per day and $500 for 5 days? Would we consider them equivalent?
It's the same.
Because it's dollars and
they're the
days,
same.
I would think.
Yeah.
That what it makes it, is that what makes it equivalent? Because it's dollars and days, both?
What's your phone number? I mean, what's your phone?
So they're both dollars compared to days. And because
Right.
they both reduce to the same rate, then we can say they're equivalent. And who's our little one, Shelby?
This is my niece, Willow. She's hanging out.
What a cute name.
Hi, Willow.
Say hi to everybody.
Does Willow want to do math with us?
Yeah, she told me I had to get back to class.
Does Willow get free donuts? That's what I want to know.
Yes, Willow does get free donuts when she wants them.
So helpful.
If Mrs. Main comes to Jackson, do I get a free donut? I need one of those hen's nest. But is that what we called it?
The honeymooner with the frosting in the middle.
Yeah, what do you call it?
They're like honeymooner. I have no idea why.
It's just like the round circle donut with the big blob of frosting.
Yep.
Yes.
Oh, right.
I have never heard of that.
Oh my gosh.
I have no idea why they're called that.
What about you?
Oh, I know. I got the hen's nest from my mom. When she would make eggs, that's what it was. She would cut a hole in her toast and she would put an egg in the middle and cook it that way. And that's called a hen's nest, I think. Sorry. That was totally off topic. Okay. So now we're back to page 158. Want to do some scaling. Was anybody able to get 3? Explain how they got 3.
30/2.
What was it?
Is it 30/2?
30/2. What about everyone else? Agree with that? 30/2.
Yeah, that's what I got.
So we could divide the top and the bottom by 2 each. Okay. What about 4?
Yeah, so I included that information into what laws to cite if we talk about laws, legal process.
Did you say number 4?
Yeah, what would our unit rate be for number 4?
15/1.
Thank you for sharing that. I know you more than happy to do so. Have you had to use it at all yet?
Okay. I agree with that. 15/1. Darla, are you good with that for number 4? 15/1.
Yeah.
15/1 hour. So that's our unit rate. And then number 5 says write a fraction equivalent to $320 for 4 days that has a 10 in the denominator. And they gave us a hint. Scale down and then scale up.
So scale down for the top and scale up for the second one?
I'm sorry, say it again, hon. I think I agreed.
Scale down for the numerator and down up for the.
I'll tell you who else. Oh, yeah.
I think that it's that you have to scale down to 1. Sorry.
No, you're right, Shelby. So we have to scale down to a unit rate is what they're saying, like we did up here, number 4.
Oh, okay.
So if you scale the numerator or denominator, if you go down in one of them, you have to go down in the other. They have to be treated in exactly the same way. So if we divide the top divided by the bottom, which means basically dividing them both by 4, right? And equivalent to 1, we get $80 for 1 day. Then once we have it to a unit rate, then we can go up to a denominator of 10 days. By doing what?
Multiplying by 10.
Right.
So we're going to multiply by a 10 over 10. So that's kind of a method of scaling down to scale up. So if you can get any rate into a unit rate, then it's easier to find a multiple of that. So I'll let everybody work on 6. This is a good kind of fun, tricky problem. If one bicyclist is pedaling at a rate of 40 miles in 3 hours and another at 50 miles in 4 hours, which one is faster? So I'm going to just let us do some work together. So number 1 and number 2, and I'll wait for you all to get some work done and we'll share strategies. I got to go write something I need. I'll be right back. Okay, anybody have anything they got worked out for number 6? Which one do we think is faster? Darla, are you talking to me? Okay, she said 4. 40? Oh, Darla thinks the one that's 40 miles in 3 hours. And so if we do 40 miles in 3 hours, if we divide them, I think it comes out to be, is it 13.33?
Yes.
13.33 miles in 1 hour for the unit rate. And if we have 50 divided by 4, this bicyclist only traveled 12.5 miles in 1 hour. So it looks like bicyclist number 1 traveled more miles in the same amount of times. That's how we compared them. Okay, so the last, if I remember correctly, yep, the last grouping of problems are all centered around this runner. This runner here at the bottom of page 158. So it says most experienced runners get to a point where they can comfortably jog long distances at a consistent pace. This pace, of course, is another way to say rate of change. Because speed is the rate at which distance changes compared to time. One particular runner jogs 1 lap around a 400-meter track in 2 minutes. You can assume that the runner can maintain this pace for a long time. So let's fill in the blanks to get us going on this. For every blank minutes, the runner jogs blank meters. So,
Wait, say it again. For every minute. Oh.
so we're just writing down the basic information they gave us. For every blank minutes, the runner jogs blank meters.
200 meters.
You said 200 meters?
Yes.
And how many minutes?
1 minute.
Okay, so you reduced it. I like that. So I'm going to put down here 1 minute is 200 meters. And the basic one that they gave us was the 2 minutes was 400 meters. I like that. Sorry, it's taking things to the next level here. Then 2, 4. So it says complete the table, continuing the pattern for times and finding the associated distances for this runner. So if they ran 400 meters in 2 minutes, how many meters did they run in 4 minutes?
800.
800. Okay. And then it looks like they're expecting us to kind of go increments of 2. So 2, 4, 6, 8, 10, and 12 minutes. So we'll go ahead and find the distances for the 6, 8, 10, and 12. So if we added 400 minutes to get to 800, then we're going to add another 400 meters. I'm sorry. So it'd be 1,200 meters, 1,600 meters, 2,000 meters, and 2,400 meters. Is everybody good with that?
Yeah.
Excuse me. Okay, and so we're going to use that information on that table to answer questions 9 through 15 on page 159.
So for 10, would I use my reduced for 10 would I use 7? For every 1 minute the runner jogs 200 meters.
For 10, it says write the runner's rate as a fraction using meters in the numerator. So the information they gave us was the 2 minutes they ran 400 meters, but they want us to put meters in the numerator. So how would we write that fraction?
400 over 2.
Yeah, so and make sure, let's put the units on there so we keep track of that.
Right.
400 meters over 2 minutes, that will help us. Let's go back to 9 and make sure it says, notice that the rate at which a runner's distance changes is constant. When the runner changes constant, a quantity illustrates what type of growth. So what type of growth are we showing so far?
A steady growth.
Mm-hmm. So when it's a steady growth, was that
200 every.
like linear growth or exponential?
Linear.
400 meters each time.
Yep. It was 400 meters each time. And did you, Zaria, did you shout? Did you say something? I just didn't hear you respond.
Linear.
Okay. I would agree with linear because it's a constant 400 meters that Darla said. So linear growth. Make sure we note that. So this is all about linear growth. So now it says, write this rate as a unit rate in meters per minute.
I think this is where that reduced unit rate comes in. The
100 over 200.
So 200 meters over 1 minute.
Yeah.
Yeah, this is where Darla or Daria took us ahead. She was already.
Nope, that was the other one. It was Sarah.
Yeah, Zaria was telling, she got us ahead, didn't she, on earlier? She was like all over the 200 meters in 1 minute.
I was overthinking it and I didn't have to.
That's okay. That's good. That's why you're already thinking about this without having to walk through it. That's great. So it says, convert your rate from question 11 to meters per second using dimensional analysis. So we've been given meters per minute. So I'm going to write what we were given over here, meters for 1 minute. And they want meters per second. So I'm just going to write meters for 1 second. This is what we want over here. And so the meters, the good thing is we don't have to do any unit exchange for meters, right? It's the same method, measurement for length as meters, but we do need to exchange minutes for seconds.
Well, 60 seconds in a minute.
Okay.
Right.
And how are we going to, how are we going to write that? Seconds on top or minutes on top?
Minutes on top, 6 at the bottom.
Okay. And why is that?
So the minutes cancel out and you have seconds at the denominator.
There you go. So our minutes canceled. We have meters over seconds. Beautiful. So this multiplies to be 200 over 60. And that reduces to be
3.333333.
okay, so 3.33 we'll say meters per second. That's our unit rate there. And then this was a unit rate too, and 11. So remember on the prior page, when we got down to the unit rate, then we were able to build up to the 10 days. So now that we've got unit rates, we can use these if they ask us some future questions, right? So 13 says, what distance will the runner cover in 40 minutes?
They don't want much, do they?
They don't walk much. Is that what you said?
They don't want much.
Oh. So what distance will the runner cover in 40 minutes? So I gave it away. We're multiplying by something.
Did someone else get 8,000 meters?
Okay, what'd you do to get that?
200 times 40.
Okay, so if we multiply by 40 minutes, our minutes cancel, right? And we have 200 times 400, or 200 times 40, which would be 8,000 meters. Good job. And notice 800 meters is our distance, right? Okay. And then it says, what distance will he cover in 40 seconds?
You did the same thing with seconds, right? Like we did in 12.
But you say the seconds unit rate, that one?
Mm-hmm.
So 3.33 meters per second multiplied by 40 seconds. And we get, is it
113, 133.2.
0.2 meters per second. Okay. This one was 8,000 meters. Oh, this is just meters. This is not per second. This is just meters. Got a little carried away. So 15 says, based on the previous two questions, 13 and 14, can you write a formula for finding the distance traveled by an object when you know the speed and the amount of time traveling at that speed?
Number 14, you have 133.2, but 3. Oh, never mind. I forgot the other 3. Okay.
You're all good.
All right. And based on the previous two, can you write a formula for finding the distance traveled by an object when you know the speed and amount of time of travel at that speed? Possibly.
So what can we, if we look, follow kind of what we did up here, our distance, the 8,000 meters and the 133.2 meters, that was our distance, right? So we want to see if we can find, how did we find distance? What did we use?
Distance over time.
It was what?
Sorry. Oof, distance over time.
Distance over time, is that what you said?
Mm-hmm.
Do we have distance over time? Because these, what did we call these?
Multiplied by time.
We did something times time, you're right.
The unit rate.
Yeah, these are unit rates. So unit rate
Times time.
Yep. And maybe like, I don't know, physics class, probably not physics, but you know, other math classes, you might have seen the formula D equals R times T, and that's this, distance equals rate times time. We just developed it. We're genius. Okay, so the last question is a little bit of an extension question. It says on page 160, what would this runner's total time be for a 10K race? Your answer 11 might help. So I had a student not use question 11, that formula. They did it a different way. Also recall that 10 kilometers is this 10K thing. And recall that 1 km is 1,000 meters. So a 10K race, they just say 10K, but it's really 10 km. So we know something about his speed, right, from the previous page.
He does 200 meters a minute.
Right.
He does go 200 meters a minute, yeah.
$2,000 meters.
You got how many? Well, it's asking the time. So we're trying to exchange this 10 kilometers for time. So
okay, so 200 meters in 1 minute. $10 minutes.
10 minutes?
Yeah.
How big it there?
And 10 times 200? No. Yeah.
10 times 200. So we have a 10K M, right?
Yeah.
So right now, all we know from the unit stuff is that we know using meters. So we probably should put that 10 km into meters, right? Translate it to meters first.
Well, 1 km equals 1,000 meters.
Right. So how many meters do we have then in a K and a 10K race? It looks like we have 10,000 meters. So we have to figure out how long will it take him to run 10,000 meters. This is the distance, right? From our formula, this is the distance that he's going to run. And we want to know how long is it going to take him to do that.
So
you have an idea? So if let's look at that formula. Distance equals rate times time. And we know he's traveling 10,000 meters, right? And we know his rate is 200 meters for a minute, 200 meters for a minute, right? Yeah, he's fast. And so we're missing time. So for every 200 meters, he is a minute. And then he runs another 200 and that's a minute, and another 200 and that's a minute. And we would have to keep subtracting those from the 10,000, right? To find out how many of those groups of 200 meters it is, to find out how many total minutes.
Is it 50 minutes?
50?
Yeah.
You are right. What'd you do to get there?
I eliminated time on the right side and divided 10,000 by 200.
Okay. So if we divide both sides by 200, we get time. 10,000 divided by 200 leaves us with 50 minutes. The meters cancel out. Hi, Carter. We're just finishing up. But you're welcome to join in and ask any questions.
I'll just wait till the end when you guys are finished.
Okay. Seeing if the ladies have any questions on this last one. Everybody good with that?
Yeah.
Sounds good. Anybody have any questions on like the things that we covered tonight, or the Unit 1 project, or the Unit 1 review?
I'm struggling to make my pie graph on Excel, and I've done it before, but I can't seem to make it work now. So it's not really a math issue. It's more of a technical skill issue.
So excuse me, let me, my computer, or my Zoom is hesitating here. Gosh, it's really hesitating. I'm trying to share my screen from our JetNet together. Can everybody see that? I'm going to go to, okay. I'm going to go to, let's do an example here. So on the student example, for the pie graph, so what I was doing today, where'd this go? It's taking a minute for it to all come up. So I see right down here where I'm circling, I just use my big categories. So I found percentages of my week, because the subcategories, it's too much for the subcategories. And then trying to do percentages per day doesn't work because not every day looks the same, right? So I did, I mentioned that the other day on the video on Tuesday, but so I just said, go ahead and just do the main categories. And once you find out the percent that you plan for each category, and then you calculate the percent of your week that you had that actually happened, you can just make your own little table down here. And then once you do that, I grabbed my category or my column names and everything, and I went down and grabbed it all. Oh, you want to do the pie graph first. So the pie graph, I did a new one down here. So the pie graph of, I did a pie graph, let me move this. I did additional stuff from what my student did, but so for the pie graph, if you can just show me what you had planned, because it shouldn't be that far off on what you had actual, you're only going to make one pie graph. So if I grab my category, my planned, that one column, and then I'm going to delete this one and pretend that it's not there. So I've highlighted what I need, and then I'm going to go to insert, and this is in Google Sheets. I don't know, Excel should be about the same, but I'm going to do a chart. It's just slow. It's getting, and then pie chart came up, and then right there it is.
Okay.
Let me copy what I have here, and let me just put it in an Excel, since you're doing yours in Excel. Let me show you the process. New. Okay. Okay. So I'm just going to drop my data right here. Whoa. Well, that was weird. Okay. It's just super slow. Oh, I was gonna say, why is it not copying it? Okay, so now I'm gonna do it in Excel. So everybody see my table in Excel? I'm gonna grab my category. This is weird. What is this thing that it's doing here? Okay, I'm gonna grab this. What? I'm not trying to draw, people. I'm just at home. Okay. Okay, so I'm grabbing my categories and my percent planned, and then I'm going to go up to insert in Excel, and I'm going to go over here, and they actually give some little pictures, which is kind of nice. Do you see that? And I'm going to hover over the pie graph, and I'm going to say insert a pie graph, and it's going to have a drop down. I'm going to choose the very first one that says 2D, and then voila. And then if you go over here to this, like, looks like a sand filter thing. I don't think that's what I think you want to do the plus sign. Do the plus sign. And then you can do data labels, and that should give the percents right in the data labels.
Okay.
And then you can edit if you just click on the percent plans, you can change your title if you want.
Okay.
My week by percent of my plan time per major category or something like that. And then for the pie or the bar graph, that is like comparing your plan versus your actual. Then in this little table I created, I just grab all of it. And then I'm going to say insert. And then I'm going to go over to this, not that one. I'm going to do this bar graph thing. And then I'm going to do a drop down, and I'm going to do the first one again that says 2D. And right there it is. And my blue is what I planned to do for my week. And my orange was actually what happened.
Okay.
And then I'm just going to click on chart title, and I'm going to edit that just to write something so I know what it is.
Okay.
Was it helpful?
Yes.
Yay.
Yeah, for me too. That's where I'm stuck at.
Huh?
I said, yeah, that was helpful. Me too. I was stuck there.
Okay. And then I did a big video in JetNet linked to the project description of how to do the apportionment stuff. Oh, Carter. Well, I think we're good. I'm going to say, and I think Carter had some other questions too. You guys are welcome to say for his other questions, but other than that, we'll plan to finish up 2-3 and then start 2-4 and see where we get on Tuesday. But the 2-3 lesson check is not due. I made that due on the 10th. So don't worry, even though we're a little ahead, it's not due this Sunday. I pushed it to the 10th.
Okay. Thank you.
What's due on the 10th?
The lesson check for 2-3, it was kind of listed under today and
Okay.
or this week, and we only got half done because we were kind of a little day behind. So I pushed it to next week anyway, so it's fine.
All right. Thank you.
You're welcome. I hope your weekend's on a better note.
Yeah, I hope so too.
Yeah, me too.
Night.
Good night.
Hi.